All right. Hey, digital crew. So we have moved on from Astro 1 and we're moving on to Astro Part 2. And you might be asking yourself, well, aren't we done? Well, that's the question, right? We've already completed a topic on space, so what is left to talk about? What is there? Think about it for a second. All right. Boom. Here's a list of what we are going to cover in Astro 2. So a couple things that you might have said in class came up. Some people said aliens and space travel and dark matter, and of course at some point maybe we'll talk about those things. But in terms of the things that will show up on the Regents at the end of the year, this is a list of the rest of the space topics that will have questions specifically about them. So rotation and constellations, models of the solar system, seasons and revolution, sun's movement / path during the day, and what the moon's phases look like, the tides, and eclipses. And one of the big things about Astro 2 has to do with our observations from Earth. So in Astro 1, we looked at a lot of just data and things as they are in big picture. But now we're really looking at, well, the things in the sky. We're thinking of things from a human perspective in terms of looking up and just making observations. And so that's where we start in the notes, celestial observations. So first off, let's start by talking about the celestial sphere. So this is a concept that evolved from the idea that if you just look up at space, it almost seems like it's all one very flat object that has things on it, right? Stars and planets. And so if you really think about extrapolating that outwards, visualizing what that would look like around Earth, it would look like we were in a big bubble, and that bubble just has a bunch of information on it, like just one wall that surrounds us. That is what we would think of as the imaginary sphere surrounding Earth, or the celestial sphere. Now with that celestial sphere, we only see half of what we would think exists, right? You can only see from the horizon, which is where the sky meets the Earth, up to the point over your head, which we call zenith. And so that right there is like a big dome that goes over our heads, and that's what we see of this celestial sphere. The altitude and azimuth are two ways we can talk about things in that celestial sphere. So let's just quickly look at a picture. I'll come back to that in a moment. So if we wanted to look at what we're talking about here, the sphere is the bubble here. And you can see in the middle is an observer, and you've got zenith, the point directly overhead, 90 degrees from the horizon, that line that goes around the base. And then with altitude and azimuth, well, we already played with altitude before. When we were talking about Polaris and its altitude from the horizon, that was telling us about our latitude. So we've already used altitude, right? That angle that it makes from the horizon. The only thing we haven't talked about yet is azimuth. So azimuth is the direction that you would be facing. Now let's go back to this picture here. Imagine you wanted to talk about the Eagle Nebula. You wanted to tell someone exactly where it was. And let's say that this right here is a bit of the, I don't know, northwestern sky. Well, you couldn't just say it's, up in northwest. There's a whole sky right there. So to be very, very exact, that is when altitude and azimuth kick in. Perhaps you would say something like that was 20 in terms of the altitude, and then the azimuth was something like, they are numbered in 360 degrees. If this was in the northwest, maybe that was something like, I don't know, 290. So these are all ways that we can figure out how to talk about things in the sky, looking from Earth. And just to be more clear about azimuth, north starts at 0, and it goes up just like you would in math in terms of the different numbers given to a circle. So once you get from north to the next 90 degrees, that would change direction from north to east, south, and west. However it goes, I don't know if I'm backwards on the camera. But so each one of those is a 90-degree turn. So for instance, north would be 0, south would be 180. So this is just a system that we can use to help us, and this is that idea of that celestial sphere in a bigger picture, help us locate things on this map right here to give us an idea of how to look for things in the sky. So, in terms of other observations, we can look up and see that things move in the sky. Now, they don't move too quickly, and you have to look every, I don't know, 15, 20 minutes, maybe every hour to really see big changes. But stars do actually move in an arc across the sky, just like the sun. And what's really cool is if you take a long exposure photo, you can see the trails that the stars make as they go around a single star, and that star is Polaris. That is aligned with our axis, right? Earth is on a 23.5 degree axis, and it lines up with Polaris. So when it spins, all the stars around Polaris spin. So you get this really cool image. There's a video in the next slide. I would definitely watch it if I were you. Tongue-tied. So this leads us to circumpolar stars. Since we're talking about Polaris and the stars that go around it, well, if Polaris is high enough in your sky, for us it's about 41 degrees, there are some stars that will never set. They will never go under the horizon. So we call those circumpolar, and depending on where you are, you might have more or less of these circumpolar stars. So, for example, the Little Dipper is attached to Polaris, the North Star, so we're always going to see the Little Dipper because it's way up in the sky. It's always going to be there. The Big Dipper, however, it definitely, especially if you're around trees, it might not be visible all the time. This brings us to constellations. So these are patterns of stars that people have thrown the idea or images of characters, of demons and people and dogs and all sorts of stuff. And it usually has a story, it's based on mythology, and we have 88 recognized and 70 can be seen in New York State, so we're a little spoiled in terms of how many we actually see. The Big Dipper is one of the big ones. Oh, that's my phone. So, Big Dipper is one of the big ones, joke intended, and is found actually in the Great Bear, Ursa Major. So there are some constellations that are sub-constellations, and we'll see in a moment. And also some of these are circumpolar, so some of these actually will never set depending on your location. So here is Ursa Major, and you can see here is the Big Dipper. 1, 2, 3, 4, 5, 6. It makes up like the back end and the tail, and the rest of it would be Ursa Major. So that brings us to the zodiac. The zodiac is 12 constellations where the sun will line up with, in relation to like during our daytime, on the back of it, right? It will line up and be in line with one of these constellations. So they're all in a ring, and as we go around the sun, it looks like the sun is blocking out that specific constellation. That's where this zodiac thing comes from. Again, here is a video that you could watch if you go into the PowerPoint. And interestingly enough, in terms of the zodiac signs, there is actually a 13th. I think it's the snake charmer, so definitely look that up. But it's interesting that in that, no one ever mentions the snake charmer, even though it does appear and is in that arc of signs. So who knows? Perhaps even you could be a snake charmer instead of, I think we came up with this as Sagittarius. So look into it, folks. All right, so we've been talking about observations and how a lot of what has been seen in the sky has been documented, and people have thrown their ideas into constellations. They've come up for systems on how to discuss these things. Well, it also has had an effect on how people have viewed the solar system. So if you were to think about a person who doesn't know that the sun is in the center of the universe, or sorry, sun is in the center of the solar system, then if you just look outside, if you just take a moment and really think about what it looks like to be a human on Earth, well, think about it. The moon moves in the sky. The planets appear to move in the sky. The sun moves in the sky, right? It rises in the east and sets in the west. It's moving, right? Or at least that's what you'd think if you didn't know anything else. So if you think about old models, right, where we had the geocentric model, the Earth is in the center, based on observations, that seems to make a lot of sense. Also, really, we're moving around? Don't we feel that? Why wouldn't we feel that if we were moving? These are questions we'll get to when we talk about revolution. But keep in mind, this is the old system, and this is what everyone thought based on what they observed. But since they were so interested in making observations, they continued to look, even once they had their model, looking for more things that could exist out there. And eventually they came on some data that ended up making certain things have to move in certain ways. They saw that the inner two planets, or, well, the ones that we know of as the inner two planets now, Mercury and Venus, had a weird interaction with the sun where it seemed like they went behind it, they went in front of it. So the only way that they could really figure that out is they'd have to make circles in circles and circles. And things moved like this, very strangely, where things were going around the sun, but the sun was going around us, and it started to get pretty complicated, as we'll see. But that did eventually lead to us getting to the heliocentric. Eventually, too many of the observations that they made just were getting really out of hand, and actually I'll show you in the next picture here. To make geocentrism work with all the data they started to collect, you'd have to have all these crazy rings where some things were circling other things, and they were making all sorts of weird, twirly spiral shapes. Compare that now to the heliocentrism, and it seems to be quite easy to see that one is very, very strange, and there's not a lot of reason for it, and one makes a lot more sense. So going back, the sun-centered model of the solar system, the accepted model, the true model, the big thing there that helped them figure this out was something called retrograde motion. It's something that is an illusion, and it happens when one planet passes another. They move at different speeds, they have different orbits, and so what actually happens is that there is an illusion. And really, I can try and explain it all day. I can show you pictures, like for example, this picture. If you look, this shows the two positions and how it would line up to an observer that's on Earth. So take a look at this and map it out. Look at 1 and go to 2 and then 3. Again, remember Earth is on the inside loop here, an inside orbit, so it's going to move faster. So this is a helpful picture. But honestly, even when I was in high school, I didn't understand this at all. What you can do, though, is I highly suggest you watch this video that's posted right afterwards. So this video goes into really good detail and shows a demonstration of how that illusion works. Again, it's a little bit difficult to describe, but I think seeing it and seeing the process of creating that illusion, this retrograde motion, this apparent backswing of planets as we move past them, it's very helpful. So definitely give that a shot. So how do you know we are actually rotating is what we're going to talk about next time. So until then, see you later.